So let's formalize how we show these solutions. Okay, so we do have to make the distinction between less than and greater than with less than or equal to and greater than or equal to. We did that on a line where on a number line, if we don't include the solution or the equal to, we leave it open. And if we include it, we fill it in. Okay, so that's how we distinguish between less than and less than or equal to. On a graph, on a two-dimensional solution, we're going to differentiate the equal to with a dotted line and a solid line. So the solid line means we include the boundary equal, and the dotted lines mean we are not including the boundary line equal. So the way we do this is we're going to just graph the relationship. Okay, so we're going to graph that relationship. So here we have our inequality, 2x minus 3y is less than 9. And we're going to graph this. Okay, so we're going to, well, first it actually says test the coordinate in the inequality. So we're going to test this coordinate. So we're going to go x is equal to -1. So -1, y is equal to 8. And I'm going to test it in that inequality. So -2 minus 24 is -26, less than or equal to 9. Check. So -1, positive 8, 1, 2, 3, 4, 5, 6, 7, 8. That is a good solution. So we want to find where the boundary is, because we know the solution, this is not the only solution. There's many solutions that are represented in an area in a two-dimensional inequality. So I want to know where the boundary is, and the boundary is going to be that line. So I'm going to do the equal to for this. So I end up with -3y is less than or equal to -2x plus 9. I'm going to divide by -3. Now if I divide by negative, I have to remember to flip the sign. That's very important. Dividing or multiplying both sides by negative flips the sign. And we have to also keep track of our pluses and minuses in this case. So my boundary is going to be slope of positive 2/3 and a y-intercept of a -3. So positive 2/3 is going to have a slope that looks like this. And the boundary line is not part of the solution, so we show it as a dotted line. So there's my boundary line. And since I want the y bigger, the solution that I tested here is on the bigger side or above the line. So it's consistent with my analysis, okay, my inequality analysis. Now if we're ever unsure, we test a coordinate. Okay, I can always test another coordinate. Okay, I'm going to test that coordinate there, 0, 0. So if I test it, I'm going to end up with 0 minus 0 less than or equal to 9. 0 is less than or equal to 9. Check. Okay, that should work. If I tested a coordinate on this side, okay, we should find that it doesn't work. So there's my solution. It's every coordinate above the line. And that bigger y is bigger than also indicates that. So there's a few checks here that we can do. We can do a substitution to test, and it's easy to test 0, 0. Or we can use an inequality test above or below.